Hello and welcome to 2.1. This is an introduction to radians. I'm jumping one or two sections here out of order. So you're going to find this, your homework sheet is labeled as I'm labeling it here. We're jumping to section 2.1 on your pink sheet. This is that's what homework you'll do after this. And we'll jump back to chapter 1 a little bit later, but I wanted to throw this into the first chapter. I think it fits better here. So what we're going to do is define what a radian is. A radian is a different unit of measure for angles. Okay, and going forward, it will be the way we measure angles. So the transition into radians from degrees is pretty important. The way it works is radians are often written as fractions, and they often have pi on the top. And I'll explain why in a little bit, but for example, let's take a look at something like 7 pi over 6. This is an example of degree measure that's in radians. The way it works is the bottom number is the number of sections you divide a half circle into. Okay, so let me draw you a picture here. Here I'm drawing a line to represent my half circle. So this is going to end up being the unit circle, so you can kind of see where that is. And I'm going to divide this half circle into 6 sections. Now they're not, they should be exact 6 sections, and they're not going to be exact just because I'm freehanding this, but we want equal sections. Okay, so I've got 1, 2, 3, 4, 5, 6 sections there. You can also then divide the bottom half of the circle the same way, but the denominator number is based on a half circle. Okay, so we've got 12 sections altogether. The top number in the fraction is the number of sections you count over. Let's say count from the start. So remember that this is our start always at 0. And if it's it works just like the degrees with positive, negative. It's a positive fraction, so that means we're going to count this direction, and I'm going to count 1, 2, 3, 4, 5, 6. Yes, this does count. The x-axis counts. 7. So this right here is 7 pi over 6. And if we want to look at the angle itself, so it's the start is here at 0, here's my terminal side, and it's this distance all the way around that is 7 pi over 6. Okay, that's how they work. Negatives go around the other direction, positives go counterclockwise. So let's take a look at another one. Let's look at 3 pi over 5. So I'm going to draw my half circle here. Now the reason that I don't draw the y-axis in this picture is because sometimes the y-axis is not part of my division process. So look, for example, at this first, at the 7 pi over 6. This is actually the y-axis right here, coming through here. But that is part of my division because 6 is an even number. But in this example, 5 is an odd number. So in order to divide into equal 5 parts, I actually don't want to use the y-axis. See how I kind of skip where that would have been? That's not one of my dividers. So that's why I don't draw that vertical to start with. Okay. And the same thing is going to happen down here into my 5 sections. They're supposed to be equal, so imagine for me. And the 3 is how many I'm going to count. So I'm going to go 1, 2, 3. So this angle, starting here and ending here, is 3 pi over 5. Okay, now it's kind of weird to get used to at first, but once you get used to it, it's actually easier than degrees because you don't have to have such big numbers that you're subtracting from. You're just counting basically, 1 through 10 or something like that. Now, why is there a pi in it? Well, let's talk about some geometry from high school. The circumference of a circle is pi times the diameter, or some of you memorize that formula as 2 pi r. Both are the same. So if we're on the unit circle, that means that the radius is 1 because it's the unit circle. So let's plug into this formula. The circumference is 2 times 1 times pi. So the circumference all the way around the circle is 2 pi. All right, now let's go back to our previous example and let's count some things up. I've got my circle here divided into fives. Here's 1, here's 2, 3, 4, 5, 6, 7, 8, 9, 10. So this all the way around is 10 pi over 5. Reduce that. 10 divided by 5 is 2. This is 2 pi. This is not a coincidence that these two are the same number, because all the way around a circle, the circumference all the way around is 2 pi. And that's why there's a pi in all of your radians, because there's a pi in the equation for the circumference. Similarly, if I ask you what is the distance halfway around this circle, you would say, oh, well, it's half the circumference. So this should be pi, right? It's 2 pi divided by 2, which is pi. Well, look at it. 1, 2, 3, 4, 5. This is 5 pi over 5, which reduces to pi. So what I want you to notice from this, the takeaway that I want, is, first of all, how to count up your radians. But as far as this pi business goes, I want you to know that this is 0, my start. This is always going to be pi. And then, so that's 0 to pi. And then as I come back around here, this is 2 pi. That's what I want you to take away. Some other numbers that you should probably just have in your head. This is pi over 2. It's halfway between 0 and pi. And this is 3 pi over 2. So what I like to do is say, you can pretty much just forget the pi and treat it as a fraction, and it makes a lot of sense. Okay, this right here is half of that top half, which is a quarter. This is a whole half. This is 1 1/2. Okay, and this is all the way around. Okay, radians are not always in fraction form, and don't always have pi on the top. So let's take something like pi over 4 and look at where that is and talk about a different way to write it. I'm going to divide into 4 sections because that is what the denominator is. The numerator is a 1. So pi over 4 is right here. Now if I take my calculator and I actually divide that out, I say, what is pi divided by 4? I get 0.785. This number is also in radians. So you can express radians as decimals. It's just not quite as common to do that. And if you just divide out some of your answers as you go, you'll see kind of what they are in decimal form. Roughly it looks like this. If I've got an XY coordinate system here, and here's my circle, 1 radian is about right here. 2 ends up being about here. 3 ends up being like here. 4, I can't remember which side 5 lands on, but somewhere in here, and then 6. So it gives you kind of an idea of where the decimals fall out. This decimal, 0.785, that would be a little bit less than 1. That would be right here. I'm not super concerned that you understand where and what they look like in decimal form. What you're going to see in calculus is in this fraction form. I just want you to know that that is happening as well. Okay. Homework problems. You will need to convert radians to degrees and vice versa. So let's do this direction first. I'm going to give you something like 3 pi over 4, and I want to know what that is in degrees. The way you do that is you multiply. It's actually a unit conversion if you've taken chemistry. This is 3 pi over 4, it's in radians. So I want to put radians down here and degrees up here so that these guys cancel off. If you've not taken chemistry, don't worry about it. Just I'll give you the formula here, but I just want to make that connection if you have. And what you need is some kind of a ratio between degrees and radians. You can use any ratio you want. What I do is I go up here and I say, one easy thing for me to remember is that pi is 180. So I use that conversion rate. Pi radians equals 180 degrees. And then you multiply the tops, multiply the bottoms, and divide. So on my calculator, I'm going to go 3 pi over 4 times 180, and then I'm going to divide by pi. So I get 135, and that's my degree measure. And that will always be the case. You take your radians, you multiply by 180, divide by pi. In order to go from degrees to radians, you just flip this conversion ratio over. So say I want to convert 135 to radians, degrees. So I put degrees down here and radians up here so that the degrees cancel. And I have 180 degrees and pi. So I'm just flipping over this ratio from the previous problem. And multiply straight across 135 pi over 180. And if you do that, 135 divided by 180 and put it in fraction form, it's 3/4. So this will be 3 pi over 4. So that's how you get back and forth between those two. And that'll be the first set on your homework. The second thing is going to be how to find arc length. There's a formula. You do not need to memorize these formulas. I will give you them on the test. It's called S equals R theta is the formula for arc length. Let me define these for you. The radius is exactly what you'd hope it to be, or R is what you'd hope it to be. It's the radius. Theta is the angle that's within the circle, and S is the length of the circumference of the circle on that little pi piece. Okay, and your homework problems will give you 2 of the 3 pieces, and you just solve for the one that you don't have. So for example, the arc length is 5 and theta is 60 degrees. Find the radius. Now, the thing you need to remember about these problems is that theta must be in radians. So if you have a problem that starts with degrees, the first thing that you need to do is convert that to radians. So I'm going to put my degrees down here, my radians here, and I'm using pi radians to 180 degrees. So I've got 60 pi over 180, and if I reduce that, 60 divided by 180, and put it in fraction form, I get 1/3. So this is pi over 3, 1 pi over 3 if you will. Okay? And now I'm going to just plug that into my formula. S equals R theta. So theta is pi over 3. R is what I want to find. And the arc length is 5. Divide that by pi over 3. And R is going to be 5 divided by pi over 3 is going to be, you can either write it as 15 over pi, flip that bottom thing up, or you can give me a decimal. That's fine too. If you go decimal, we should get 4.77. Okay? That's how you do your arc length problems. And the last formula for this section is the area of a circular sector. The formula for that is A equals 1/2 r squared theta. So a problem might look like this. Give you a section. This is going to be r, this is going to be theta, and the thing we're finding the area of is this pi piece. Okay. Oh, also with these, theta must be in radians. So let's say the problem says find the area of a sector with radius 5 and theta equal to 120 degrees. So again, first thing is to take 120 degrees and convert it into radians. So I get 120 pi over 180, and 120 divided by 180 in fraction form is going to be 2/3. So this is going to be 2 pi over 3. And then I plug into the formula. So they want to know the area. My radius is 5. I'm going to square that and multiply by 2 pi over 3. So this is going to be 25 over 2 times 2 pi over 3. So this is going to be 50 over 6 pi. And if you want to, you can reduce that, or you can go into decimals. If you go into decimals, that is going to be 26.18. I don't have any labels in here, but there will be labels like if it's in centimeters, centimeter squared, or whatever. But that's the idea of the math. So you can take a look at problems in section 2.1. Okay, make sure you're there, not in chapter 1. And you can either start them now, or you can wait till the lecture and do them after the lecture. So it's your choice, and I'll see you next time.